Okay, so we're going to look at categorizing prime and composite numbers, and there's actually some that are neither. So I'm going to start by making my key. I am going to use green for prime numbers. I'm going to use yellow for composites. And I'm going to use orange for neither. So there's only one number in your 100 chart here that is neither prime nor composite, and that is the number 1. 1 only has one factor that goes into it, which is 1, and so that makes it very special. It is neither prime nor composite. Numbers that have only 1 in themselves with no other numbers that divide in evenly are prime. So 2 is prime. Okay, and 3 is prime. So what I think we'll do is go through and mark all the primes first, and then we'll go back. So 2 is prime, 3 is prime because it's only 2 times 1 and 3 times 1. There's no other factors. 4, however, is 2 times 2, so that's going to be composite. So 5 is prime. It only has 1 and 5 that go into it. And 7 is prime, and that is it for the top line. Anybody want to guess what one is next? What prime number comes next? 11 is prime. And 13 is prime. And then it skips over a little bit to 17.
Oh, we could know this.
And 19.
Because of the chapters in the book. Yeah.
Okay.
273 is prime.
And then there's going to be fewer as we go. So on the next line, it's 23. And then 29 is the only other prime number on that list. So as things become multiples of other things, it just doesn't work. So anything that's in columns of even numbers are going to be composite because they divide by 2. So it's not going to be a lot of numbers as we go. So the next line, 31 is prime. And 37 is prime. And then the next line has a few. So 41, 43, 47. And then come down to the next one. We've got 53 and 59. And then 61 and 67. And we're almost done. 71, 73, skips around a little bit. 79, 83, 89, and on the last line, 97 is the only prime. So those are your prime numbers, and you'll notice there really isn't a lot of patterns. People have spent a long time trying to figure out how do I get the next prime number and the next prime number as they get really big, and there's some formulas that have been made and different things, but they're kind of hard to pin down for us. So everything that we did not mark as prime is composite, and you can take your composite color, and every column that has all even numbers, you can kind of just color in all together. So that's kind of a time saving. So all of these, so 2 is the only even number that's prime. That's a knowledgeable question every once in a while. They'll pull it out. What's the only even prime number? And it is 2. Every other number 2 goes into if it's even. And so, okay. And so then we've got, underneath the 5, you've got a bunch of multiples of 5. So those are all going to be composite because they divide by 5. 21, 51, 81, 91, 33, 63, 3. It does seem like there's a lot more prime numbers that end in 1, 3, 7. And I guess it's just because they're not even. Okay, so I didn't color them perfectly, but you kind of get an idea. This is going to be a good chart to look at as we go to simplifying radicals in a little while, because this is going to help us with the prime factorization. So we didn't spend a ton of time on prime factorization when we were doing things in middle school. It's kind of a thing you do really quick and keep going. But prime numbers only have one in themselves. Composite have other numbers that go in, and then 1 is the only one that's neither prime nor composite. So there's a little trivia there. We are probably going to be using the prime numbers on the top row the most, 2, 3, 5, and 7. Occasionally there might be an 11 or something else in there. So this just gives you something you can look back at if you're not sure what other numbers to try, that sort of thing. So I'll give you guys a second to finish coloring, and then we will look at some examples. So I am just looking back in my notes to see. Okay, so. It's all right. Okay, lots of coloring. So another minute or so, and we'll have to keep moving, or my video is going to be really long. Somebody just listening to me talk into the microphone.
You should tell a story.
Don't have a good story about this. Okay, so I think I'll just flip over here and we'll wait just a second, and then we'll go through how to do these. My internet's going kind of slow. Okay, not what I wanted. So, all right. You may want to have this open where you can see your prime numbers. So we're going to write the prime power factorization of each number. So what that means is we are going to break the numbers down into prime numbers that are being multiplied. So, and I'm going to teach you what's called the birthday cake method. I like it better than using a factor tree. It's just been more successful for me in teaching. So we're going to start with 75. So we're going to build a birthday cake. You have to build it from the bottom up. So I'm going to go down just a little bit and give myself room to build up. And I'm going to put 75 and then a long division thing. Okay? So give me a prime number that goes into 75. There's a couple of them. 5. So if I divide by 5, I'm going to get, what is it, 15? Yes, 15. Okay? So now I'm going to build another tier. I'm going to put another little division symbol here, and I'm going to divide by another prime number. So guess what? 5 goes into that one too. And when I take 15 divided by 5, I get 3. So 3 is a prime number, so I can divide it by itself, and then I get 1. I know I'm done when I get the birthday candle on the top, which is just, you keep going until you divide and get 1, and then you can make it into a birthday candle. I know, exciting. So what that means is the prime factorization of 75 is 5 times 5 times 3. And a lot of times they'll write it as 5 squared times 3, or 3 times 5 squared. So that's what they call a prime power factorization, because we're using power, so writing it as factors. I know. I wish I had birthday cake too. I've never actually brought birthday cake in for this. It hadn't occurred to me, and nobody's ever asked until you guys, so it's interesting. Okay, so let's look at 65. So 65 will also divide by 5. So if I see it ends in 5 or 0, that's always a choice. And it goes in 13 times. And if you need to, you could use a calculator for that. I was just doing the long division in my head. Now, prime number that goes into 13 would be 13. That's it. So I'm going to divide by 13. I get 1. There's my birthday candle, and I'm done. It's just 5 times 13. That one's kind of boring, and it's not a very big cake. So they call this the birthday cake method because you make tiers and tiers until you get to the one at the top, which looks like a birthday candle. Okay, so let's look at number 3. So I'm going to take 82. Remember, we're giving ourselves some room to build up, so I'm going to take it down here. What's a prime number that'll go into 82? Now, it ends in 2, so that's a hint.
2.
So if it ends in an even number, you can always try 2, and that goes in 41 times. So then I'm going to look, is 41 prime? It is. So on here, they are using some of those bigger numbers. And then there's my birthday candles. So this one is just 2 times 41. This is going to help us simplify some square roots. And so that's why we're kind of doing this now. Okay, 72 is going to be a bigger one. So I'm going to make sure I have some room for 72. 72 also ends in a 2, which means I can start by dividing by 2, and I will get 36. And then I'll divide by 2 again. I get 18, or I'm sorry, that's supposed to be 2. Dividing by 2, and I get 18. And it's still even, so I'm just going to ride the wave here. Divide by 2, I get 9. So I can't divide by 2, so it's a prime number that goes into 9. 3, so I'm going to divide by 3, I get 3, and I just barely have room here. It's going to be a tiny little candle on the top. You keep going until you get to 1. So this one I have 2 times 2 times 2 times 3 times 3. So that's a prime factorization. If we're using powers, we'll do 2 cubed times 3 squared. Because of that repeated multiplication, they just simplify it down like this. I'm just going to draw some lines to kind of keep my work neat. Okay, we ready for the next one? Okay, so we've got 69. Will not divide by 2. So what prime number do you think will go in? 3. 7 will also go, well...
Wait, no, that's 49.
I think that's 49. So 3 goes in 23 times. And then I have to think, 23, and I look at my chart, oh, that's prime. So it's just another short one. So I just get 3 times 23. I don't even need powers. It's kind of a boring one. So they're kind of a mixed bag. Some of them are really quick and some of them took a while. Okay, so let's try 92. What do you think will go into 92? I need a prime number. 2. And then when I divide, I'm trying to think what we would get. What is that, 46? And it's still even, so I'm just going to divide by 2 again and get 23, which is prime. We just had that one, so we'll divide by 23 and get 1. So you're always dividing by prime numbers. This one's going to be 2 squared times 23. Okay. Okay, so then number 7 is 88. So where do you think we should start?
2.
2. So that's going to give me 44. Then what?
2.
Divided by 2 again. We get 22. Then what?
Divided by 2.
Divided by 2. I get 11.
That's a prime number.
Prime number. So we'll go ahead and divide by 11. And we stop and we get the 1. And we make it look like a little birthday candle. And if you want to color the flame, go ahead. And so we're going to write it as 2. So 2 times 2 times 2 would be 2 cubed, and then times 11. So it's not too bad, and you can use a calculator if you don't want to do long division. Let's do one more, and then we'll make the bottom two our practice. So let's do 85. What do you think? So it's good. How many times does 5 go in? So 1, I think it's 17. Okay, and then what do I do with 17?
It's prime, isn't
It's
it?
prime, yeah. So just divide by 17, and look, we're done. So 5 times 17. So why don't we use 9 and 10 as our practice, and I will stop video.